Good afternoon and welcome to this month's show. I'm Luke McCormack. During today's show, we will discuss best practices using machine learning and artificial intelligence in the government. With me on today's show are Gregory Allen, Chief of Strategy and Communications, Department of Defense Joint Artificial Intelligence Center, Jose Arrieta, Chief Information Officer at HHS, Keith Rayle, Senior Security Strategist, Fortinet, Varghese, Chief Information Officer, Noaa Fisheries, Nick Psaki, Principal Office of the CTO, Pure Storage, and Melissa Sutherland, Vice President of Defense Military Intelligence for Booz Allen Hamilton. Well, the White House recently had a second IA summit, the second one in 6 months. I understand they had industry there, academia there, and most importantly, almost 30 agencies talking about their use cases. And I thought what was interesting is we've really moved from thinking and planning to more of implementing and operationalizing. And when you look at AI these days, you know, there's sort of two dimensions. There's an organic build, and I'm sure we're going to talk about all the capabilities that are happening there. And there's also the purchasing of goods and services and software that have AI and ML embedded into it. So lots to talk about today. Greg, let's start with you and just give us a state of the state. There's a lot of activity going on over at the JAIC. A lot of great press about what's happening there, boosting some of the funding, et cetera. Well, give us the state of the state.
Sure. So my organization, the Department of Defense Joint AI Center, which we shortened to JAIC, is still a pretty young organization. We were actually established in the middle of 2018, but we started getting money and people just about February of 2019. In that past 7 months, we have scaled up a frantic pace of activity and have some pretty exciting results to share what's going on right now. We have 3 national mission initiatives. These are projects covering the types of missions that we're looking to use AI capabilities to support, and we're about to hit some exciting milestones in each of them. For our most mature mission initiatives, Humanitarian Assistance and Disaster Relief and Predictive Maintenance, we're about to begin testing of some interesting capabilities. In the case of Humanitarian Assistance Disaster Relief, which we shortened to HADR, we are now about to begin testing with the California National Guard for an AI system that automatically detects and geo-registers the location of wildfires. So if you're familiar with wildfires, these range over extremely large areas, and actually telling the first responders where the fire is and where it's moving is a real challenge. This is the sort of thing today where they get a paper acetate map and it's distributed to them on a relatively infrequent basis. And by the time they get it, it might be 8 hours old. So we're able to fly an aircraft, take overhead imagery of the wildfire situation, use an AI algorithm to automatically analyze that imagery, and then geo-register the location of the wildfire so we can provide near real-time updates to National Guard and other first responders. That allows them to plan more effectively and efficiently in their operations. And even though this effort really only got funding starting in about February, in just that 7 months, we're about to begin testing with our end user community. And that's a really exciting pace of AI activity.
That's fascinating that you all are doing that. I know just sort of reading some of the post reports out of some of the California fires that was a big problem, right? Situational awareness. Jose, how about at HHS? I know there's a lot of activity going on over there these days.
Yeah, well, thanks, Luke, and thanks for having us on the show. So over about the last 2 months, we've actually done 2 things with artificial intelligence. First, at HHS, we spend about $17 billion a year in professional services expenditures. So the first thing that we did is we took GAO reports on what determines if a contract's inherently governmental or not. And we use that as a framework to analyze our professional services expenditures. We actually read through about 9,000 statements of work using natural language processing. We indexed every word with a number in those statements of work. We created a vector, pushed it into a predictive model, and then came up with a confidence score as to whether or not the statement of work being performed was could be inherently governmental or not. We then took it a step further and actually read through labor categories, personnel descriptions, and job descriptions in this pilot, and we connected them together. As you know, the hardest thing in analyzing pricing for professional services is understanding apples-to-apples comparisons. So by doing that, we've actually taken labor categories, anchored them to PDs for government positions, and now we have a string where we can look at the cost of a government employee, the cost of a professional service provided by Company A, and a cost of professional service provided by Company B. So that we did that over about a 6-week period. It's a proof of concept. We think with an 86% confidence score that we've identified around $111 million in savings, and we're not forcing that decision on the workforce. What we're trying to do is share that information with the workforce and then use their feedback to kind of fine-tune our model. And so it's the beginning of a deep learning capability. We built it in-house. We didn't use an existing product. We felt that it was cheaper to test it in that way. And then if we went to scale it on an enterprise level, we would look for products in the marketplace that could scale at an enterprise level. The second thing that we did over the last couple of weeks, and we did this at zero cost through an existing ELA, is we looked at our TIC, our Trusted Internet Connection, and we said, geez, it would be great if we could analyze everything hitting our TIC in real time, which is structured data, leveraging a neural network. We used a recurrent neural network on the professional services stuff. We're using a neural network on the TIC data because it's structured in nature. And so with a very quick proof, what we've been able to do is take the data that hits our TIC and what happens over a 24-hour period, we can analyze in a matter of seconds. And we used to do it with an analyst, and it would take 4 to 5 days. And the idea is that we can then use what we've learned from the recurrent neural network, and we can extend that to unstructured data sets that we have from a cybersecurity perspective, and we can start to create characterization around threat information, around the structured data that actually hits our TIC. So those are kind of the two proofs that we have going on. We're pretty excited about them.
It's incredible when you start thinking just these examples of when you can open this aperture up and really put a high-powered machine on these capabilities, what you can come up with. Keith, Fortinet, you guys are right in the middle of this from a technology base, enabling all this, and you're seeing a whole bunch of different activity going on. Give us a state of the state as to what you're seeing out there.
Well, currently, we're at the point where we've taken about 10, 11 years to develop out some systems. And our whole goal is to ensure that threat intelligence is not only broken down into these bite-sized kind of chunks that can be used for combating cybercrime, but also that threat intelligence sharing among systems and things. And so, for instance, we have an AV system that we started, that was about 11 years ago, and it has 17 billion code blocks that it uses as the basis of this massive neural network to detect malware. We've taken that and leveraged it into connected systems now. And that particular one actually has 3 AIs built into it. One of them does this massive stacking and racking of all those code blocks, ranking them according to their importance. Another system ingests net new malware and inserts that into that stack carefully so we don't mess that up. And then we have another one that QAs signatures that are pushed out automatically to our customer base. And all this happens automatically. It was done by engineers. And that's another goal of what we're trying to accomplish with our systems, is to be able to take these highly sought after, scarcely found technical security resources and leverage AI so that they can do the important things people do. And we do that with that type of a system. And we also are starting to connect machines now, which is kind of interesting. We're taking an AV output, and we'll use what's called a sandbox, where we can actually detonate malware and analyze the bits and pieces. And we have artificial intelligence doing that now in such a way that the output is according to an attack framework that the analysts can now simply open up, look at, click on the specific IOCs, the indicators of compromise, these things that happen as that malware blew open, and determine what types of systems were being attacked within the infrastructure. And at that point, chief information security officers, people responsible for the security protections within an environment, start to see more clearly where they should be spending their money and protecting assets.
Zero their way in and do it at light speed, sort of the needle in the needle of the haystack, right, type situation. Roy, how about over at Noaa Fisheries? I know there's a lot of activity going on over there. I'm fascinated, very interested to hear what type of activities are going on regarding AI and ML in the fisheries.
Thank you, Luke. Just to give you an idea of what Noaa Fisheries does, we're part of a 4,000-person organization, mostly fishery scientists and experts who are passionate about the work that they do in terms of protecting the species that are in our ecosystem and ensuring that we have a sustainable protein source from the marine life, right? And that's a big part of what we do. And for us to be able to do our jobs, we need to have more knowledge about what's going on in the ocean. And that requires, in the past, human observers collecting information, collecting samples, analyzing that data, making scientific predictions that informs our fisheries management.
Mm-hmm.
In the new world, with the advancements of science and machine learning and AI, we're able to leverage some of those technologies to expedite those scientific advancements. I'll give you a good example. One of the areas of responsibility for us is to protect and preserve the whales, beautiful, majestic creatures that sparks everybody's imagination. It's one of the reasons why I like going to the beach, hoping to see a whale someday. But we only know so little about them because they are mostly underwater. And we have to collect information about them, to study them, to figure out where they go, what they eat, when they mate, so that we can continue to protect their habitat. So we have collected, our Pacific Fisheries Science Center have collected almost 170,000 hours of audio recordings of whale, right? If a human were to listen to that and make sense of it, it will take almost 19 years of uninterrupted time to make sense of that and classify it. Using Google's AI for social good, as well as partnership with our researchers, we're able to develop patterns to recognize different types of whale songs. So we like to call it songs because they are beautiful, but they also have meanings. And we are able to derive those meanings using AI. And the more audio recordings we have, the more accurate that will be. And we're making that available for the world also.
Absolutely fascinating use case. I mean, it's just really compelling. Nick, if you're going to use AI and ML, you have to be able to store all this data that's being collected, stored in an efficient way, have it rapidly available, et cetera. You're sitting right at the precedent of that. Tell us what's happening over in Pure Storage.
Well, Luke, as you said, it's a new world of computing, and it requires a different approach to the compute architecture. Neural networks, as an example, have really different performance characteristics compared to the architectures that we have built in the past to handle our general enterprise compute. So at Pure Storage, we've worked with our partners NVIDIA and Cisco and Arrieta and Mellanox to create an architecture specifically designed to support the massive parallelism, concurrency, and throughput requirements for processing, or for training artificial intelligence algorithms and for working with these enormous sets of data, because as we've frequently discovered and hear from customers, it's actually the amount of data that is crucial for the development and training of artificial intelligence and machine learning algorithms. So you have these massive data requirements that require incredible throughput, because a DGX1 or a DGX2, as an example, has nearly 100,000 cores of compute, but you absolutely have to keep all of those cores fully saturated with data, and in order to, number one, have a meaningful outcome, and number two, get the value out of the infrastructure that we put into it. So you have these massive throughput requirements, and that really requires a different approach to how do you build systems to support this. It's sort of in a very similar analogy, you have to actually put the right kind of tires on your race car in order to get its maximum performance out. Well, the data service platforms in these architectures are really the foundation of the architecture.
Sure.
And we have built a pretty elegant solution for delivering the kind of performance necessary to handle those problems of volume and velocity that are acutely apparent in AI and machine learning architectures.
And certainly acutely apparent in the federal government, right?
Yes, indeed.
An entity that has massive amounts of data. Melissa, I know that you're working in different parts of the federal service, or have in the past, and are now, where there's a lot of data, right? And on defense, military, and intelligence. Tell us what are you seeing out there, and what's Booz Allen Hamilton up to in this regard?
Yeah, no, thanks, Luke. Absolutely. I think the biggest challenge we're seeing with our clients and our customers is the sheer volumes of data that are out there now. I mean, when you think about the fact that 25% of the data coming in now is real-time data in the present, How do our intelligence customers, our defense customers process all that data to support their mission? And it's further exacerbated by the fact that a lot of the data is tightly coupled with the systems in terms of where it lives. So how do we pull all that together and help analysts who spend an inordinate amount of time going out and hunting all this data down so that they can aggregate it to capitalize on machine learning and AI to make their job a lot easier? So we've also partnered with companies like NVIDIA and invested early on in AI to help put in place the type of algorithms that are going to support the analyst. One of the areas I'm currently supporting our customers with is a concept called Analyst 2.0. How do we empower the analysts with the suite of tools through these algorithms to get through mass amounts of data? I'll give you a couple of examples in particular where we see a lot of aggregated data is around social media analysis and the onset of open source intelligence that the intelligence community is struggling with now. We've created a couple of machine learning and AI algorithms. One's called Prometheus that can actually go out and identify extremists operating on social media that might have an alternate front. So how do we use machine learning algorithms to go out and pick up the social indicators and cues that allow us to know that that's profiles of interest for our client? And we can summarize that list down so that they can really focus their time on analyzing the right data sets to have impact on the mission. Another algorithm we put in place is related to Global Pulse, and same thing, it goes out and scours a multitude of social media sites to aggregate and highlight and put those trends in front of the analyst to support their job. So we're supporting customers today with those algorithms in the space to have that type of impact for the
Right,
intel
really
analyst.
fine grain and getting the products in front of them so they can go up the value chain. Roy, I would imagine based on what you had described with that activity, that has to have fisheries really excited. Is there another program out there you'd like to highlight, a specific one that's really making a big impact over there at fisheries?
Yeah, so going along with the theme here in terms of the massive growth in data, we're also seeing the same thing. Back in the day, we used to collect data in logbooks and such, and now we're collecting data slightly differently. And we're also collecting large amount of audio data as well as video data, and those data it's coming from remote locations or from sea. Moving that data efficiently across the network into a place where it can be analyzed is a big challenge that we're looking at. Developing a data sharing platform for scientists and collaborate so that collaboration can happen more effectively. It is not just a technology challenge; it's also a social challenge, right? And that social engineering challenge. So I think that's one of the things that we're working on right now.
Right. Just having that, putting that framework out there, and laying the tracks down, if you will, the plumbing, to have the capability, to have the storage, to have the high-speed networking capability, to then get it to the point where you can use these GPUs and start doing the machine learning and the AI to come up with these fantastic use cases that you're describing. We're going to take a short break and we'll be right back. You're listening to the Federal Executive Forum on Federal News Radio, part of the Federal News Network. Welcome back to the Federal Executive Forum on Federal News Radio, part of the Federal News Network. With me on today's show are Gregory Allen with Defense Joint Artificial Intelligence Center, Jose Arrieta with HHS, Keith Rayle with Fortinet, Roy Varghese with Noaa Fisheries, Nick Psaki with Pure Storage, and Melissa Sutherland with Booz Allen Hamilton. We were talking about specific programs, specific examples. I'm going to throw it over to you, Melissa. Can you give us a specific example of an activity that Booz is working on that you'd like to highlight for the listening audience?
Yeah, absolutely. One of the things we really want to capitalize on is the reuse of machine learning and AI out there in the community and how we leverage these algorithms. So one of the things we've internally invested in is how do we create a library of these algorithms, but also start thinking about the deployment model, taking best practices from the software industry. How do we automate the deployment and provisioning and training of these models so that we can take more readily take available, make make them available to our customers with the data. So some of the areas we focused on, a recent effort, we partnered with Kaggle to launch a data science bowl focused on social good. So we looked at how do we tag, parse, and curate the data so that we can look at trends around speeding cures for diseases, for example, or detecting and diagnosing heart disease. So leveraging those algorithms, we were able to aggregate that data and even bring in some of our interns that work with Booz Allen that are versed in working with a lot of the sources in which we were pulling in to have impact. We were able to actually take some of those models and retrain them and deploy them in the intelligence space as well.
Wow, that's incredible. I mean, these use cases are just phenomenal, and to be able to take a use case where you've got some algorithms that are dealing with heart disease, and then be able to port that over to some sort of intelligence activity is pretty incredible. Greg, how about at DoD? I know you guys are doing some really just knockout programs over there. Give us an example of one that you'd like to highlight.
Sure. Well, as I said, we at the JAIC, the Joint AI Center, are a pretty new organization, just stood up really with funding and people since February of 2019. In our sort of three major initiatives at the moment, we are trying to get access to end users to make sure that they can try out our capabilities and that we can wring those capabilities out to make sure that they are precisely what they want. So in the case of our Humanitarian Assistance Disaster Relief in National Mission Initiative, which I mentioned a bit earlier, we're about to begin testing with the California National Guard related to a wildfire detection system, and then we're in parallel going after another system that can relate to flooding. So this is a capability that's currently in development, but we'll begin testing with end users in the National Guard and elsewhere shortly, that can automatically analyze satellite imagery of a flooding area, for instance, the kind of a disaster that you might see after a hurricane, and it can analyze the roads that are in that situation to determine which roads are blocked because of flooding, which roads are blocked because of fallen debris, and which roads are still open and available to be used by first responders. So this is able to take satellite imagery or airborne imagery and turn it into something that looks a lot more like a mobile phone mapping application, and actually does use file standards that are relevant to that. That's a capability that we still have in development today, but we're moving very quickly. It's really just a matter of months before we're going to put it in the hands of end users and ask them, what do you like about this system? What can we improve about this system, et cetera. That's one of our key lessons learned in the development of any AI program, or really any software program, is that you need access to end users of your system during the development process, because you need their insights about their daily work, how it might fit into their normal practices. And that's really one of the best practices that we found in terms of developing and delivering any AI capability.
Right. I mean, that's agile delivery at its finest, right? Just being able to continue to iterate and get feedback from the user, tweak the product, get it out there. Flash to bang, how long has that taken you guys to do that as far as this project?
It absolutely depends upon what type of capability you're going after. In our case, we're looking to integrate with legacy systems related to airborne sensors and geo-registration. These are technologies that have sophisticated processes for integration with them for good reason. It matters that these capabilities work. And so the people who say we want to work with those capabilities better be able to demonstrate what they're going to do to ensure that it does work. For other capabilities where you're going after non-mission critical data, non-safety critical data, and applications like back office, you can really make an impact in a much shorter time frame. We have a relatively new initiative that we're kicking off now related to intelligent business automation. And it's looking at using natural language processing and machine learning to sort of automate the processing of many DoD forms in the back office. Those are areas where you really can make an impact in a matter of weeks or a short number of months. But for other areas where you're going after sophisticated sensor platforms, the integration takes a longer time, and it should take a longer time.
Of course, and you could crank those capabilities out, but you have to be careful about it. Keith, how about at Fortinet? Can you give us an example of a program that you'd like to highlight for the listening audience?
The explorative areas that we can use AI for, as far as solving these problems that we have, we're only really constrained by what we can conceptualize or come up with. And right now at this company, we have so many ideas of how we can take massive amounts of data and leverage that into clearer and deeper threat intelligence. For instance, we have over 500,000 devices around the planet that collect intelligence, these attacks and things that are happening in networks. and feeds it to us. We get billions of attacks per, in a matter of minutes that we're sifting through trying to find new things. And it's a massive amount of information. We've been talking
Right. And
really,
trying to do
really,
it in
really
real
big
time.
data.
Yeah.
But now imagine being able to take that in a deeper type of analysis or capability. For instance, cyber criminal organizations, there are some fairly large ones, and they have structure. They have CEOs, CIOs, CFOs, CTOs, and all the directors and things, and they're fairly well organized up. And one in particular, for instance, is called the Shadow Group, and they did this little trick of jackpotting ATMs, where they would gain control of an ATM, and they would have one of their people there hitting certain keys in certain order, as directed on the screen, and the machine would spit money at them. They've had 5 major campaigns that we know of, about 400 to 500 of these code block IOCs, these indicators of compromise that we can use to analyze them. And so we can almost kind of build out a playbook of how they operate, a DNA footprint or a fingerprint, if we are, or whatever you want to call it, of how they operationalize their activities into cybercrime. Now, if we can take artificial intelligence and gather the metrics on this known group, even apart from the malware they use and things, but we start thinking about the timing of their attacks, where they originate from, where they're targeted to, the level of attacks, how they're carried out, et cetera, and start plugging these in. Not only do we get the deeper insight as to how they operate, which is, it's good from a, hey, I can see that. But now we can become more predictive, and when they're going to strike next, where they're going to strike,
Right.
and what their methods are going to be, so that and it's actually you're literally looking at the DNA of a group's operation with artificial
It's
intelligence.
interesting. You always hear about AI and the predictive maintenance on a GE aircraft engine, right? And sort of the algorithms associated to that. Who would have thought you could have the predictive outcomes and algorithms associated to the CIO of the Castronauta or something like that. Jose, how about at HHS? I know you guys are doing a whole bunch of different activities. Give us a specific program that you'd like to highlight.
Yeah, I think
where you're going deep on AI and ML.
it's interesting as I listen to the group. So we have FDA Informed, which is what I was going to talk about, but I think which is a program that is bringing together data from external sources and internal sources to deliver better health outcomes in a number of areas. But rather than talk about it, I think it's really interesting here is how do you actually kind of scale up and do this work, right? And so the approach that we've been taking at HHS is we identify a problem and we hire someone to help us solve it at a very low cost, right? And maybe that's a small business, and then we move to another company. We bring in another company that can maybe run multiple development teams at one time, because as Greg keeps pointing out, you have to develop a user interface that the workforce is going to be comfortable with.
Got to integrate it.
So they can create more. And then what we realized is that then you have to go to a larger integrator with maybe a technology platform that can kind of service you at an enterprise level. And so the approach that we've taken to do this at a low cost and kind of build in change to the workforce is start by solving a problem for a couple $100,000, bring in somebody that can run multiple development teams, that can create a UI that our workforce will be comfortable with and help us generate buy-in through human-centered design, and then go to market where we're looking to an integrator and a technology provider to partner together. The technology provider saying, look, this is a part of our R&D investment. The integrator saying, look, we can use this to sell capabilities to other government agencies, both domestically and around the world.
Reuse.
And I think that's the way that you actually kind of scale and drive change in these organizations and in our organizations, and actually control for risk. And as I listen to the conversation around the table, I think as important as it is to talk about what we're doing with machine learning and artificial intelligence, it's important to talk about how you're actually driving that change. Because if we went to market with a large technology provider and an integrator to actually do the work, the change would be so big that it would be hard to drive in a federated environment like we work in.
Sure.
Right? So we've been taking it in bite-sized pieces, and I think that's something that needs to be a part of this conversation, both today and in the future.
Right, and sort of that whole federation of activity. Not only do the agency, most of these agencies operate in a federated way, you need to implement these types of capabilities in a federated way.
And you have to go and you have to look across a series of, and I hate to use the word silos, but you have to look across a series of organizations and you have to go horizontal across them, and you have to modernize the tech stack while delivering on your legacy operations.
Right.
And that's a tough balancing act if you don't have a strategy to actually execute it. And I think
Right. And there's always that tension, that healthy tension against, sort of your legacy environment where your system of records are, et cetera, and trying to, modernize and sort of this net new. I would imagine, Nick, that you face this all the time as folks are trying to, migrate and, digitize and modernize in a modern way. And maybe you can give us an example of some dynamics that you're seeing out there in the community around that.
Yeah, to extend on what Jose said, very often we find that customers, agencies, and organizations start with a small effort to validate a proof of concept or validate a strategy, and then scaling it into production entails getting substantially larger and better integrated hardware and software capability. But where do you find that? Because in a lot of cases, the types, as we said before, the types of architectures necessary to performing this at scale are relatively scarce at the moment.
Sure.
You can certainly go to the cloud, but we've certainly done that at Pure Storage, and suddenly you find yourself with 20 petabytes or more of data. And managing that and controlling cost and scaling the architecture requires a completely different skill set than what we might have developed in our own people talent, and perhaps, even the capabilities necessarily don't exist in the cloud service provider. So the question becomes, where can you go to get the things you need in order to go from the test drive to full rate production? And that's a question that industry is tackling aggressively. And it's also interesting that the solutions aren't coming necessarily from quarters that we would have anticipated. Who would have thought 10 years ago that NVIDIA would be in the data center business?
Sure.
Or who thought 10 years ago that memory-based storage would be the prevalent type of storage that's consumed in the market today? We are seeing a wholesale transformation across the industry to address these very particular requirements for the types of computing and the types of problem solving and the types of outcomes we're trying to deliver, that's as radically transforming the compute technology as the smartphone did cellular communications.
Yeah, please.
I'd just like to, I think that's a really good point. So, one of the challenges we ran into when we were building our recurrent neural network is that we're talking about doing a series of things, and you get to a point where whatever you did before no longer matters, right? So you have to forget what has occurred before and make a decision. It's like you're walking down a hill and you come to a cliff and you no longer can take a step. You either have to slide down or walk around. So from a storage perspective, memory has to be stored differently. Transactional memory, long-term memory, and memory associated with motor skills like RPA have to be stored in different locations. So the approach that we've taken is go really light on infrastructure and just kind of show what our boundary will be. Really heavy on user interface. Now we can, and then some tests. I can prove return on investment, and then I can start to think about how to implement a storage strategy that's going to allow me to be flexible long term to actually deliver the return on investment that I think I can capture. And I think the piece on storage it's kind of one of the challenges that we kind of bumped into, and I'm glad we didn't go and build the infrastructure first. And I'm not that old, but I think that historically government agencies have focused on building out like a large infrastructure first, and they've limited all their flexibility downstream.
And I think that's where these cloud services capabilities have really entered the scene. You were talking about who would have thought, even Amazon 15 years ago going from selling books to what they're capable of doing today. And not all the clouds are the same, right? There's different dynamics there. We're going to pivot over to talk about lessons learned. I'm going to start with you, Greg. You all are early adopters, early implementers, many of you in this space, and I know you're discovering a lot of lessons learned. We always like to highlight this for those that are maybe not quite in the same situation that you all are, so that they can learn from these capabilities. And when I say lessons learned, I'm talking lessons learned pluses and minuses. So Gregory, please.
Sure. I think the important thing to realize is that not every problem is a good fit for AI's capabilities today.
No way.
It is.
Say it again.
And not every problem is a good fit for AI today. So if before you kick off your project, find out if this is a good candidate for an AI solution. That's certainly the process we go through. Here's sort of the basics of our checklist. is this a problem where we're going to have access, to relevant data sets? Who is the owner of those data sets? How will we get the access to them and be able to run machine learning algorithms on these data sets? Will we have access to end users to try out our initial capabilities? Your first prototype, your first minimum viable product of an AI system usually is not a home run. What you need is feedback from the end user to make it better and better over time. And then the third aspect is this an area where there are mature machine learning and artificial intelligence capabilities in commercial industry or in academia? Is there stuff off the shelf that you can use? If you have those three things, your path to driving impact rapidly in AI is quite a bit better. And then I'll say there's another thing. That's how to identify what you might call low-hanging fruit AI projects, although I don't want to suggest that low-hanging fruit means it's easy. Sometimes it's very hard, but there's a difference between hard and impossible. But at the same time you're identifying these low-hanging fruit projects, how are you ensuring that each one of these successes is building momentum towards greater success in the future? And in our case, we have an AI infrastructure team that is building a common foundation initially for our own projects, thinking about what is the type of environment that we need from an enterprise cloud capability, from a DevSecOps software development platform that actually can make it easier to develop the next round of machine learning projects. And this is a really exciting initiative that we are going in parallel with our sort of other projects, the national mission initiatives around humanitarian assistance, predictive maintenance, and cybersecurity that I mentioned before.
Yeah, it sounds like a lot of iterate and reuse, and I know, Melissa, you were saying something very similar to that, where Booz is onto that. You're doing quite a bit of that. Some lessons learned from Booz Allen Hamilton.
Yeah, absolutely. So one of the biggest lessons learned is really how do you operationalize these models? So it's great to do them in a lab with a defined or artificial data set to start to train the model and get it deployed. The challenge then becomes getting it in a real-time environment, and in particular, our intelligence customers, they're in a cross-domain environment. So they have an unclassified network, a secret network, and a top-secret network. So we've been looking at how do we take best practices from the software industry, from digital transformation, using approaches like DevSecOps to automate the deployment of software. We're looking at how do we apply the same concepts and technologies on automating the provisioning of machine learning algorithms. And leveraging things like microservices to package them. We have a saying, train once and field forever. That's while we have done that with software and deployed things like platform as a service capability that we could build on, it's difficult to do with the algorithms. A lot of times these models are static and it takes a lot of manual time to train, and it's difficult to reuse them in some environments. So we've been looking at how do we automate that and capitalize on that so we can reuse, and we're not doing mass amounts of time redoing these for each problem set.
Yeah, reuse is key. That's definitely the name of the game. All right, we're going to take a short break. You're listening to the Federal Executive Forum on Federal News Radio, part of the Federal News Network. Welcome back to the Federal Executive Forum on Federal News Radio, part of the Federal News Network. With me on today's show are Gregory Allen with the Joint Artificial Intelligence Center, DoD, Jose Arrieta, HHS, Keith Rayle with Fortinet, Roy Varghese with Noaa Fisheries, Nick Psaki with Pure Storage, and Melissa Sutherland with Booz Allen Hamilton. We're talking about artificial intelligence and machine learning, and we were getting into lessons learned, pluses and minuses. Jose, let's throw it over to you and just give us one example, one lesson learned for the listening audience, a plus or a minus.
Yeah, I mean, I think that we learned early on to prioritize effectiveness over efficiency. So, from my perspective, I want to be very effective versus super efficient and bite-sized steps and pieces. And what I mean by that is right now in some of the work we've done, we have multiple application layers, and we have two different sets of functioning infrastructure. And essentially, that's probably not the most efficient way to actually execute what we're executing, but it's the most effective way to actually understand what's going to work best as we scale from an enterprise perspective. And it allows us to get products out there to the humans, to our user base, quickly so that we can get feedback. And I think that is really important if you want to be successful. Now, I go back to the storage issue. Being able to take an interaction that occurs and separate it from a storage perspective into 3 different locations is extremely important for your long-term ability to deliver an enterprise solution, I believe. So long-term memory, transactional memory, motor skill memory, running RPA, taking behavioral information as it relates to access and usage, and then maybe a large technical document or a video file or an audio file, and storing them in separate places, but keeping them interconnected to one another is extremely important for your ability to use something like a recurrent neural network downstream. So those are the two things that we didn't know at the beginning, but because we went in small bite size, we took a small bite-sized approach and we prioritized effectiveness over efficiency, we were able to learn along the way.
Effectiveness over efficiency is a very good point. Keith, you're right smack in the middle of this. What are you seeing, lessons learned? Give us a number one out there that everyone ought to take away, plus or a minus.
Well, as a vendor, you try not to come across as the only owner of a hammer when everybody's carrying nails. But the big lesson learned with our AI was probably, there were two of them. The first one is that these things take a long time to train up. Accurate systems are difficult to build and train. So there's that time factor. It requires a large investment. And architecture, you'll swap architectures around trying things for efficiencies. But it takes time. And this is, right now, this whole marketplace is flooded with vendors, yelling to have these artificial intelligence systems and things. But it's not like one of those camping tents you see in the store. It's a bunch of hoops and some fabric, and you throw it in the air and it pops open into a tent and lands. You got a place to sleep. It takes a lot of resource investment to build out a strong system. Now, the other one that we learned was to stay in our playpen. And our playpen goes back to what I'd said a little bit earlier about trying to build systems that ease your technical resource demands in the environment, because those resources are very hard to get, really strong security technical resources. And so we tend to focus our systems, since we have all this massive threat intelligence that we collect, and we share, even with competitors. We have a cyber threat alliance that we've built, and we share this stuff out, so it's better for our community. But anyway, so we stay focused on trying to solve problems that ease the resource cost and overhead within the environments. We make the analysis of malware, the understanding what cyber criminals are trying to do with it, where they're going to attack. We try to get this knowledge out of all this threat intelligence that we collect, because operationally, that allows our security professionals to leverage that and put people on more important things.
Stay focused. Yep.
Yeah.
Roy, how about an example, lesson learned, plus or minus, as an early adopter of this capability?
I think the biggest lesson learned is that you can't do it alone. It requires partnerships and collaboration, not just within the government, but also within industry partners also, and partners, small, large, all sizes and shapes and forms, because the way the technology is rapidly changing and evolving, innovation ideas are coming from all walks of life and all parts of the world. And we have the opportunity to incorporate that, and if you don't, you could miss the boat. And as everybody indicated here, research to operations is very difficult. If you don't acknowledge it, you're doomed to fail in operational mode. So that goes without saying.
Takes a village. Nick, one example, plus or minus, lessons learned.
The scale of data required to effectively train AI and machine learning algorithms is substantially larger than most customers have started or have really appreciated in the past. And Google's frequently said that the only real advantage that they have in this space is that they frankly have more data than everybody else. So the amount, the variety, the volume, and the speed with which you can get through data is really turning out to be one of the essential factors in being efficient and effective in training and developing AI platforms. And the second thing is, therefore, scaling your architecture to support that, or rather acquiring infrastructure that allows you to scale dynamically, is actually also essential as well. So you need to start looking at, is the thing that I'm buying today going to be able to grow with my agency or organization as these efforts mature? Can the data that we have be reused or leveraged by other platforms that I can bring to this architecture? So to Melissa's point, containerization and microservices have proven to be a very powerful framework for training and developing AI algorithms and subsequently deploying them in the field.
Yeah, you know,
So
it used to be
short version, architecture matters.
right, and he who had the data wins, but it's he who has the data and can do something with it wins. All right, we're going to wrap it up with a question that we always end with, and that is sort of paint a picture of the future. Melissa, we're going to start with you. You know, I know that Booz is looking over the horizon. Tell us what the future looks like in this space that's moving so quickly over the next, let's say, 2 or 3 years.
Yeah, absolutely. I think we're going to see that the automation and provisioning of these capabilities is going to grow. And Nick and I were talking earlier, not just about the storage component, but about the fact that right now, I think this technology is evolving so fast that oftentimes our analysts don't even know what questions to ask of the algorithms. And as AI advances, I think it's going to even provide us insights into questions we should be asking of the data. So as I think 5 years out from now, rather than doing what I would say predictive analytics or historic modeling in the intelligence community, I think we're going to be at a state of preventative intelligence where we can actually preempt attacks. We can actually preempt events prior to them happening by understanding and leveraging the integration of these data sources and leveraging the integration of different algorithms to be better informed around where threats reside, around how local sentiment and populace plays into how some of these events play out, as well as individual actors and some of their motivations and methods. I think we're going to be able to identify those things real time, and it's going to change the way we operate and our tactics, techniques, and procedures that are in place today with the government.
Sounds fantastic. Nick, what's the storage play going to look like in 3 to 5 years?
That's a good question. I think that we're going to start to see a transformation in the types of the media. The memory media itself is going to evolve to provide lower latency, greater capacity, and greater performance. I think that we're going to see the fairly rapid adoption of new transport protocols, such as the non-volatile memory express over fabrics, because it more adequately addresses the needs of parallelism and the reduction of latency to make these systems more efficient. We're going to see a pretty significant increase in overall bandwidth across the internet as a result of the deployment of 5G and significant efficiencies in the trunk networking and core networking of the fundamental infrastructure of the internet. And this will enable us to get more reach, more access to sensors, to deal with the profusion of sensors, and ultimately provide us, unfortunately or fortunately, with even more data to work with. So data management is going to be an incredibly important aspect of this transformation to massive scale semi-autonomous computing.
Right, and I think just you know, all this data that's going to be collected and having this technology, 5G, et cetera, to get it all back to some place that you can actually compute it and then run these algorithms is going to be incredible.
I'd say that what we want to do actually is start processing this data for relevance closer to the
Local,
edge.
yeah.
We have 55 zettabytes of data created per year now, but the aggregate bandwidth of planet Earth is 11 zettabytes. So
Wow.
we literally have 5 times as much data as we have transport to move it on. It is going to be essential because data growth is going to outstrip the growth of network bandwidth and, frankly, compute bandwidth considerably. To be able to process this data as close to the point of creation as possible and simply move the things that are relevant to us.
Yeah, and we can't forget about the ocean. So, Roy, tell us what's that going to look like, and you know, what is Fisheries going to be up to in regards to this activity over the next 3 to 5 years?
I think the way we do fisheries management will look significantly different in terms of how we collect data to understand what the population health of various species are. Right now we rely on human observers and surveys and samples. In the future, using images collected and identification of species based on same technology Facebook uses to identify face recognition, we can use to recognize fish faces, species recognition, and be able to only transfer the data in terms of that matter to fisheries management resources rather than the raw images of all those catch that is coming into the ship. So I think the way we collect our data and process it's going to be significantly different. That enables us to do our management differently. Another advancement would be the whole arena of environmental DNA, the idea that you can take a spoon of ocean water and be able to understand what living organisms are present there, or DNA of those organizations are present there. It's an emerging field that could have significant impact on how we do science. And that requires advancement in computing also to execute.
23andMe of ocean water, that's fascinating. Keith, how about at Fortinet? What do you all have going on there in the Petri dish that we'll see emerge, or just what's the industry going to look like in 3 to 4 years in this regard?
Currently, one of the primary issues that I think we see with security management mirrors the business environment as well. And gentlemen here and ladies can attest to the fact that this digital transformation is going on. We adopt these technologies we're trying to solve. We take bites here and we operationally cut down certain stacks, such as in storage. We take a data warehouse, now we move out to the cloud, then we have a shared cloud space, and we do this, that, and the other. And we shorten operational stacks and add technologies. And as security professionals, I was a CISO, Chief Information Security Officer at a company, and the bane of my existence was trying to get information and metrics out of 70 or 80 separate, implementations of different tools to protect the environment. And basically, the very difficulties that this model of adopting lots of new technologies, and it created all of these attack surfaces. And as I deployed more and more technologies to handle things like access controls, I was actually creating these cylinders of operations as well for a security perspective. But the top of that cylinder was a failure surface. This is where I was weak and vulnerable within this security infrastructure and architecture. This is where I could be hit, and I kept making these. I went from LDAP out to different ways of managing application-based and federated management.
Your risk surface kept getting bigger and bigger.
Yeah, and so the security problems that I think we're going to be looking to solve are centrally focused on threat intelligence, speed of information, and being able to rein in disparate technologies into those clear views, those single panes, if you will, that everybody's been hoping for. But I think this is where artificial intelligence will be able to help a great deal, is that integration of security into a sharper, faster, clearer view of what's going on within the environment.
Get super focused. Jose, how about at HHS? Tell us, paint a picture of the future there.
Yeah, well, I don't like talking too much about the future from the last time you guys asked me that question. But what I will say is that
we're still dazzled by it, Jose.
Yeah. I think that over a period of the next 3 years, you'll see government agencies and HHS in particular focus on how do we get the value out of all the data that we have internally and look to analyze it on the basis of external data sets that may exist and external organizations may have actually created. And I think creating for lack of a better term, the infrastructure or investing in cloud capabilities that actually allow us to do that is step one and something that has to occur. I think that Nick here brought up the point on he brought up the point on computing at the edge, and I think behavioral-based identity at the edge is a key component for HHS and for other federal agencies when you think about if we're able to aggregate the data sets that we have internally, create an ability to analyze and share it with external data sources, then we need some type of behavioral-based identity capability so that we have an understanding of who's actually accessing the network, what their behavior is, what they're doing, and I think from there artificial intelligence capabilities can bloom. So I think that's extremely important. I also think that there's a lot of M&A activity happening in Washington, D.C. right now and in the industry space, and it's based on companies that are buying into contract opportunities so that they can grow and scale. I think in 3 to 5 years there's going to be a lot of M&A activity, and where in the private sector it would be focused on acquiring data sets, I think in the government space, because the U.S. government owns most of the data, it's going to be focused on AI capabilities and infrastructure that can actually do things with the data sets government has. And I think that's going to be a pretty interesting change from the way industry is behaving right now in the marketplace.
On the move. Gregory, you talked about a lot of fascinating things that are going on over at the JAIC, and I know that DIUX is in there doing some incredible stuff. Big uptick in funding that's coming in the out years. What does it look like in 3 to 5 years?
DIU is doing some terrific things, and DIU has been a terrific partner for the JAIC. In fact, we actually have some staff who are co-located at DIU facilities.
Wow.
So painting a picture of the future, I want to point out that our new Secretary of Defense, Secretary Esper, named artificial intelligence as his #1 technology modernization priority in his congressional testimony. And the reason why that's true is because we believe AI capabilities offer incredible potential all the way from the DoD back office to the front lines of the battlefield. So we're imagining a future in which AI capabilities span the breadth of military robotics, command and control systems, cybersecurity, and intelligence surveillance and reconnaissance. In each of these areas, you can point to exciting AI technologies where you really can make an impact. I talked today about some of the programs that we're moving out with. Those are the programs that we chose because we wanted to move out quickly and deliver impact quickly. Our organization exists to deliver capabilities and mission impact for the DoD services and components. But that's only a small fraction of what we see as the overall potential of AI and what we're moving out towards, which is why I think over the long term, one of the most exciting things that the JAIC is working on is our Joint Common Foundation. This is going to be an AI DevSecOps platform whereby different organizations within the Department of Defense can come and use our system to develop AI and ML tools and then get rapid development and rapid delivery to their end users with a path towards authority to operate. In the Department of Defense, it's completely routine to see software updates come every few years. We want to get to a path where software updates are coming every day. Based on user feedback, based on what we're encountering in the field. And we know there are parts of the Department of Defense that live that right now. Air Force Kessel Run is one impressive example, but we want to enable that for ML-specific capabilities, and we want to enable it for the entire Department of Defense.
Rapid deployment, rapid application, a great way to end this. I'd like to thank today's guest for taking time out of their busy schedule to join us for this program. I'd like to thank our sponsors for without we don't have a show. I'd like to thank the good people here at Federal News Radio that make this program so successful and enjoyable. And most of all, I'd like to thank you, the listening audience, that tune in every month. You're listening to the Federal Executive Forum, part of the Federal News Network.